There are a few things I forgot to mention from this video. So, if you look at this dendrogram again, and then I also copy and paste my analysis from SPSS to various Excel spreadsheets. So, as you can see, counties with ID number 1 is close to counties with ID number 56, 57, or counties with ID number 30, 18, 28, 7, 12, and 36. So, if you look at the proximity matrix here, we can see that counties with ID number 1, if you look at this row, is quite close to counties with ID number 2, 3, and 4, and counties with ID numbers 56 or 57. Or counties with ID number 12. And this explains why they are all assigned to the same county. And this is the same thing, just with the county names. So, if you go back to the spreadsheet, as you can see from here, I ran cluster analysis or hierarchical agglomerative cluster analysis using different clustering algorithm. I tried average linkage. I also tried complete linkage, single linkage, nearest neighbor. And I also tried decentralized methods, which you cannot see here in this spreadsheet. So, this, when you run hierarchical agglomerative clustering with SPSS, you will see this, what is this called, agglomeration schedule, as one of the SPSS output. This agglomeration schedule just tells us which counties by their ID numbers are assigned to which cluster in what stage. Let's make this bigger. And if you scroll down, we can see that counties with ID number 1 is assigned together with counties with ID number 57. In step 39. And if we scroll down further, counties with ID number 1 is also assigned to the same cluster with counties with ID number 18 in step 41, like 2 steps further. The last column talks about the steps involved in assigning counties to different clusters. And if we scroll a bit further, we see that counties with ID number 1 is also assigned to the same clusters with counties with ID number 12 in the 46th step. And if we go a bit further in this spreadsheet, we see that counties with ID number 1 is also assigned to the same cluster with counties with ID number 5 in the 50th step. And then counties with ID number 1 is assigned to the same cluster with counties with ID number 56 in the 53rd steps. And counties with ID number 1 is assigned to the same cluster as county with ID number 3 in the 56th step. So this is what we see here. And if we go to the tab that says proximity matrix, you see that the values are pretty close. The differences in this matrix, you see that the values are pretty close. So it makes sense why these counties are assigned to the same cluster. So this is how we make sense of the cluster assignment, by looking at dendrogram, the proximity matrix, and the agglomeration schedule produced by SPSS. And if we compare analysis conducted using different algorithms, they came to almost the same conclusion. Sometimes we just repeat our cluster analysis using different algorithms to see whether the results are consistent or not. If the results are not consistent, we got to find out why. So as we can see, the results are pretty much consistent between the average linkage algorithm and the complete linkage algorithm. And if we run single linkage algorithm, we can also see that there are consistency among our results in terms of the three algorithms, and the same thing for nearest neighbor. And for this data set, the results from nearest neighbor clustering method is very similar to single linkage clustering algorithm. This may not always be the case. I think it depends on the values of the variables we have in our data set. The results are very similar, as you can see, among the different algorithms. The steps may slightly differ among the algorithms, but the results in terms of which counties should be clustered together are almost the same among the different clustering algorithms. So this is how we try to understand how different counties with different values for different variables in Louisiana are assigned to the same clusters using hierarchical agglomerative clustering. We can compare the results we get from SPSS analysis, or there's also a way to write our syntax for average linkage, complete linkage, single linkage, or nearest neighbor, or the Watts method, or the median clustering method. All these clustering algorithms produced by SPSS can also be done in R programming language. So we just compare the output by looking at the steps involved in terms of cluster assignment, and then we look at how our dendrogram looks like, just to make sense.